So today we're going to take our discussion of angles a little further and talk about some different angle pairs. We're also going to bring in some ideas with parallel and how that allows us to find the measurements of some angle pairs in a relationship that has parallel lines. So today, let's learn some new vocabulary. There are a lot of words today, but just trust me, once you get working with them, it will stick. So first of all, I've got two lines here on my screen that are in black, and there's a red line that's crossing them. So it's like there's two streets, black, and a red one coming across and hitting both. That red line, first of all, is called a transversal. It transverses across those two lines. Now, the blue angles that are inside those two black roads, those are called interior. They're inside. They're interior angles. They lie inside the two lines. They're angles 3, 4, 5, and 6. Now, the green angles, which are 1, 2, 7, and 8, are called exterior angles. They're on the outside, the exterior of those two black lines. Now remember that an angle is made up of two rays and it has an endpoint. So angle 8 I'm tracing right here. Angle 7 I'm tracing right here. You might notice that angle 7 is an obtuse angle. Angle 8 is an acute angle. And if I was to add the degrees of angle 8 to the degrees of angle 7, I get a straight angle, which is 180 degrees. So angles 7 and 8, since they're going to add up to that straight angle, add up to that 180 degrees, angles 7 and 8 are supplementary from our discussion in our review from 7th grade. If we look at angles 7 and 6, notice that there's an X being formed here with this black line and the transversal. And angles 6 and 7 are opposite V's. They're opposite angles in that X. They're called vertical angles, and angles 6 and 7 would have the same measure. Just trying to bring back a few words from our previous lesson, but I just want right now for you to understand what a transversal is, what interior angles are, and what exterior angles are. Before we move forward, let's just remember some symbols and some language. Parallel lines, this is the symbol. Perpendicular lines, it's an upside down capital T. The parallel lines look like train tracks. And what does it mean to be parallel? Parallel lines never intersect. They go on and forever, but they will never cross each other. Perpendicular lines do intersect, they do meet, and they form right angles or 90-degree angles. If you were going to draw it, there's a pair of parallel lines, and there is a pair of perpendicular lines. Where can we find parallel lines in the real world? I just mentioned a second ago, train tracks would be a really good example. And then perpendicular, if you've ever been to New York City is a very nicely gridded city, so that the avenues and the roads, the streets, come together in right angles. Very easy city to get around in because of that. So there would be an example of perpendicular, an avenue coming in connection, in intersection with a street in New York City. So here's an example again of the perpendicular. There's line M, perpendicular line N. Remember that little box means it's a 90-degree angle. So these two lines would be perpendicular, and this is the symbol. Here's two lines that are parallel. And if you notice these little triangles like on there, that's the symbol that lets you know that they are parallel right on the figures. And if you look down here, the symbol for parallel is those train tracks. Up here, you can see the right angle, which tells you that these guys are perpendicular. So that's just some symbols that will kind of help you see that. So this page has a lot of words. And what I want to tell you is I'm going to walk through them with you right now. But the next few slides will give you a nice picture of it using color. So just go with me for right now, but this page right here is really important. It kind of has everything that we're going to learn today, all of the new words. So we just mentioned what a transversal is. So a line that intersects two or more lines is called a transversal. So you'll see line L, I'm tracing it. It's a transversal because it crosses these two lines right here. We just mentioned interior angles. So if we look at this picture, angle 3, 4, 5, and 6 are all on the inside of these two lines. They're interior angles, and angles 1, 2, 7, and 8 are on the outside, so they are exterior angles, and that's kind of what they're saying right here. Now we're going to bring in the word alternate. Alternate means on opposite sides. So let's look at our interior angles. So we're only looking at 3, 4, 5, and 6. And if we were going to name a pair, a duo of two angles that are alternate interior, first of all, we can only look at 3, 4, 5, and 6 because of the only interior angles. And when we say alternate, we want one on the right and one on the left. So 3 and 5 would be a pair of alternate interior angles. So would 4 and 6. And those are the only pairs of alternate interior angles in this picture. Let's change that word interior to exterior. Now we are only looking at angles 1, 2, 7, and 8. We look at one on the left and one on the right. So 2 and 8 would be a pair of alternate exterior angles, but so would 1 and 7. The last one is the one that oftentimes people confuse a little bit, and it's called corresponding. I'm going to just take angle 2 right now, and I'm going to trace it. Do you see angle 2? And if I was to take that angle and slide down to the other line, do you see how angle 6 is in the same position? So another way is to look at these 4 angles and notice that 2 is in the upper right. And when you come out down here, do you see that angle 6 is in the upper right? They're in the same position, both 2 and 6, in their group. So 2 and 6 would be a pair of what's called corresponding angles. But so would 3 and 7. They're both in the lower right of their group of angles. So would 4 and 8. They're both in the bottom left of their group. And 1 and 5. There are 4 pairs of corresponding angles in this picture. So we have some relationships right here talking about what different angles are. Now we're going to talk about what if these lines were parallel. What if this line and this line were parallel? You're going to notice some things underlined here. If the two lines are parallel, alternate interior, 3 and 5, 4 and 6, alternate interior angles will have the same measure. So angle 4, if you measured it with a protractor, would have the same measure as angle 6, and so would 3 and 5. Alternate exterior angles, so again, we're looking at 2 and 8 and 1 and 7. If these two lines are parallel, they also have the same measure. They are congruent. They have the same number of degrees. So angle 1 and angle 7 would have the same number of degrees, and angle 2 and angle 8 would have the same number of degrees. One more thing, if we're talking about parallel lines, corresponding angles also have the same measure. So look at 2, he's in the upper right of his group. Look at 6, she's in the upper right of her group. They would have the same number of degrees. So here's some pictures to just kind of help you see these angles. So alternate interior, like if you look at the 2 red angles, those are a pair of alternate interior. And if you look at the 2 yellow, those are a pair of alternate interior. And here's where you can really see that if these 2 black lines are parallel, and notice the green line would be your transversal, you can tell, you can kind of see that the 2 red angles, both obtuse, would have the same number of degrees, and the 2 yellow angles, both acute, would have the same number of degrees. They're alternate interior. Let's go on the outside, the exterior. You can see to the right of the transversal outside, look at the blue, and to the left of the transversal outside, you can see those two blue angles are a pair of alternate interior, and they would have the same measure. Same thing with the two pink. The last one is the corresponding. Now there's 4 pairs there. So look at the two blue, upper right of their group. Look at the two red, lower right of their group. The two yellow, lower left of their group. And the two pink, the upper left of their group. And you can see how they have the same measure, like the red and the red, the blue and the blue. They have the same number of degrees. They are congruent angles. So here's some questions like, what can we kind of do with this? So the first thing is classify each pair of angles in the figure as, are they alternate interior, alternate exterior, or corresponding? So angles 1 and 7, you're going to see I came over here and I circled 1 and 7 in green. Notice that the number 1 angle is on the left of the transversal, 7 is on the right. They alternate, and they are both on the outside of the train tracks. So they would be alternate exterior angles. If you look at 2 and 6, now notice they're both on the same side of the transversal. There's no alternate thing here. And 2 is in the upper right of the group, and 6 is in the upper right in the group. They are called corresponding. So can you name the angles? Classify the relationship between angles 4 and 6. So you see that I've circled them here. They're both on the inside. They're interior. One's on the left, one's on the right. They are alternate interior angles. Another type of question. Which is an alternate exterior angle with angle 7? So look at angle 7, and can you right now, just stop for a second, what would be the alternate exterior angle with angle 7? Did you guess angle 1? Right up here? Then you'd be right. So let's talk about corresponding angles. How about if you pause the video for a second? Who corresponds with 3, who corresponds with 8, and who corresponds with 2? Pause for a second, think about it, and we'll come right back. Okay, angle 3 corresponds with 7, lower right, lower right. Angle 8 corresponds with angle 4, lower left, lower left. And angle 2 corresponds with angle 6. They're both in the upper right of their groups. So there's sort of the vocabulary lesson tying with the picture. Now let's start talking about how do we find missing measurements when we know these relationships. So if we look at this picture, the first thing I notice is I have 2 lines that are parallel. Those 2 little magenta pink triangles are telling me these are parallel. Here's my transversal. And now I've been given that angle 1 is 50 degrees. You can use that to find the measures of angles 2, 3, and 4. So first of all, there's a lot of different ways to look at this. But the measure of angle 1 and angle 2 form that straight angle that we talked about in our last review of 7th grade. They make a straight angle. They are supplementary. They're going to add to 180 degrees. So since they have to add to 180 degrees, if this one is 50, angle 2 has to be 180 minus 50, which would be 130. See, now I think it's the easiest in the world to kind of just do vertical angles. So if angle 1's 50, angle 3 would be 50. And if angle 2 is 130, angle 4 would be 130. And you can get those angles very quickly. Let me just back up for a second. I thought I was going to be on the next slide. You can take that idea now and kind of drop to the other group. So if angle 1 is 50, it corresponds with angle 5. So angle 5 would be 50. And since angle 4 is 130, angle 8 would be 130. You could do the corresponding angles all the way around here and be able to name every angle. So if these are parallel and you've got one angle up here, you can actually fill in all 8 angles. So here we have a furniture designer has built a bookcase shown. And A is parallel to B, and you have this kind of cool modern design with this transversal kind of going up at an angle. They're telling me that angle 2, which I'm touching right here, is 105 degrees. You can tell it's an obtuse angle. It's bigger than 90. So it's 105 degrees, and I have to find angle 6, and I have to find angle 3. To find angle 6, it's pretty easy because those two angles are supplementary. They form a straight angle here. They have to add to 180. So if I take 180, subtract 105, the measure of angle 6 should be 75. And you'll notice these two angles add up to 180 degrees. How do I find the measure of angle 3? Well, angle 3 and angle 6 that we just found are alternate interior angles. They have to have the same measure. So the measure of angle 3 is going to be 75 degrees because of that alternate interior. Okay, I'm going to ask you to pause the video right now and see if you can do the got it. It's looking at the same bookcase and it wants to know what will the measure of angle 4 be. Okay, now let's see. You could go right off of angle 2. There's a lot of different ways to look at this, but one example was if angle 2 was 105, which is what they gave me, that angle is corresponding with angle 4. They're both in the bottom left of their group, which means they have to have the same measure. So the measure of angle 4 would also be 105, and you could say that angle 2 and angle 4 are corresponding angles. So you're asked to find the measure, and then you're supposed to give a reasoning by telling, what the angle is you're looking for with one of the angles, usually the one given preferably, how do they relate? Sometimes you can't do it directly. It takes more than one angle to get there, as you'll see in the examples we keep doing. Okay, so let's just see how we made out here. Notice the two lines are parallel. They didn't even have to tell me in both of these examples. In this case, they're going to give you the measure of angle 1, which is the angle in the upper left of this group, is 85 degrees. And they want to know what is the measure of angle 5. And they also want to know what's the measure of angle 7. In this one, they're giving you the measure of angle A. Also, the upper left is 70. They want to know what the measure of angle C is. And they want to know what the measure of angle E is as well. I'm going to ask you to pause the video, see what you can do with this, and come back and turn it back on when you're ready to check your answers. Okay, angle 1 and angle 5 are corresponding angles. They have the same measure, 85 degrees. Did you put that number, and were you able to give that as your justification, as your defense of your answer? So you give the given angle and the one you're looking for and tell what relationship they have. Okay, if the measure of angle 1 is 85, what would the measure of angle 7 be? Did you also get it's 85? Now this is one where you had to, you could directly get there because those two angles are alternate exterior. This guy is on the left of the transversal, number 7 is on the right, and they're outside the train tracks. Okay, the measure of angle A is 70. How do you get the measure of angle C? Now, they are not the same measure. One is acute and one is obtuse, but they form a straight angle. If you were to add their degrees together, they have to add to 180. Did you get the measure of angle C as 110? And it's because they are supplementary. Two supplementary angles add to 180 degrees. Okay, the measure of angle D is 70. What will the measure of E be? Well, he is also going to be 70 because angles D and E are alternate interior angles. Okay, here's one more got it. If you had your book, you would be able to check this out. But they're telling you the measure of angle 7 is 35, and they're looking for the angle 1. Now, these do not have a special relationship. You're going to have to walk through another angle to get there. This is what I call a two-stepper. Pause the video and see how you do. Okay, so the measure of angle 7 and the angle 5 are supplementary. So the measure of angle 5 should be 145. Now, the measure of angle 5 and the measure of angle 1 will be the same because they're corresponding. So that's 145 degrees. There are multiple ways to get there. This is one pathway, but you had to go through another angle to get to that 145 degrees. So at this point in time, I hope you have a little bit, or at least a start to some of these relationships. Tomorrow we'll be doing some practice. Remember the videos out here. The notes page will be attached to Classroom. You can come back, you can watch, you can rewind pieces, you can look at the filled in notes page to figure this out. A lot of vocabulary, but a lot of good stuff. I hope you guys all have a great day.